In this video, we'll be using the law of sines to solve our case 2 type oblique triangles. That case 2 type triangle is when we're given the lengths of two sides and the angle opposite one of the sides. It's not the angle in between the two sides. When we're given this side-side angle situation, it's possible for 0, 1, or 2 triangles to exist. Please note that when we discussed the congruence axioms for triangles, there was not one for side-side angle. So let's talk about why this might occur, the 0, 1, or 2 triangles. So suppose we know the measure of an acute angle A of a triangle and the length of side A and side B. So that's our case 2 given. An angle and then sides and the angle's not in between the two sides. Right. So what I'm going to do next is we need to draw the side of length A opposite length A. Right, so that's this one here. It's kind of dangling. It looks weird like that because for each problem, the length of side A is going to differ. So sometimes it reaches this other side and creates a triangle, and sometimes it doesn't. So that's why the diagram kind of has it weird dangling like that. The key to determining the number of possible triangles, 0, 1, or 2, lies primarily with the height of our triangle. See, check this out. The shortest possible distance from our angle C down to this third side is a straight line. We know that's the shortest distance between any 2 points. So the shortest possible length for that side A, which is highlighted in green, the smallest it could possibly be, has to be equal to H. It might be bigger than that, but if side A is smaller than that, then it's not going to close and create a triangle. And it is true that H is equal to B times sine of A. So where are we getting that? If we look at, I got so much highlighting going on here. All right, if we look at this triangle, it's a right triangle, so we can use SOHCAHTOA, and from angle A, H is opposite and B is our hypotenuse. So sine A is equal to H over B. And if we solve for H, we get B sine A. That's where that comes from. Okay, so our first situation is if that H that we found, which is the height, the shortest distance between our angle and our side, if our height is greater than A, then no triangle is going to exist because that side A isn't long enough to touch the bottom. Now, if H and A are exactly the same, then a single right triangle exists because it's the shortest distance. There's that perpendicular at the bottom. Now, if the height is less than A, so our side A is longer than the height, 1 or 2 triangles may exist. And the reason for the option there is because we don't know what angle C is, we don't know how that third side swings. It might swing this way and touch the bottom and create this triangle, or that side A, maybe it goes down here, because remember, we also don't know the distance of the bottom side, so it's possible that it's long like this, and then we would have this big triangle here. So there might be one option, there might be multiple options. This situation, because of all these options, is called the ambiguous case of the law of sines. You're going to hear ambiguous case way more than you're going to hear case 2 law of sines. So we don't have to rely on an illustration to draw the correct conclusion in the ambiguous case. We can apply the law of sines to the values of what we're given, A, B, and capital A. Of course, those variables might change from example to example. And use some basic properties of geometry and trig to determine which situation applies. So we're going to be using these following basic facts. For any angle of a triangle, sine of that angle has to be between 0 and 1. And we're only choosing positive there, right? Because we're talking about angle measures inside a triangle and lengths of sides. If sine of theta is equal to 1, then our angle is going to be 90 degrees and we'll have a right triangle. Number 2 says sine of theta is equal to sine of 180 minus theta. That is, supplementary angles have the same sine value. We've already been using this a lot for things, and we're going to continue to use it a lot here. I guess maybe we just didn't state it exactly like this. See, when we were using inverse sine and finding sister triangles, right? Maybe we had one here with a reference angle of 20. Sine is positive in quadrants 1 and 2, so then we'd say, oh, there's another one over here. And the way that we actually got the angle measure for over here was we took 180 and we subtracted the 20, which was the reference angle. That's what this property number 2 here is saying. So we're going to use that a lot with these law of sines. And the smallest angle is opposite the shortest side, largest angle opposite the longer side. And we've been doing that as well. What I typically do with ambiguous case, and I know it's going to be ambiguous case because I'm given a known pair, so I know it's sine, law of sines, and I know it's ambiguous case because I'm only given one angle. I just always assume that there's more than one triangle, and if there's 1 or 0, it will clearly present itself to us. And don't worry, I'm going to do examples so you can see what that presentation looks like. So let's determine the remaining sides and angles of the triangle, and we'll round our answers to the nearest hundredth. I see side C and angle C, a known pair. So I know I can do law of sines here. I also notice that only one angle is given, so this is going to be the ambiguous case, and I'm going to have to, kind of be heads up for that. So side C over sine of angle C equals side A over sine of angle A. And we need to solve for angle A. We have a proportion, so we'll cross multiply. Sine of A is equal to 2 sine of 50 degrees. Since we're solving for an angle, we're going to have to use an inverse trig function here. Angle A is going to be sine inverse of 2 times sine of 50 degrees. And we're going to plug this into our calculator. Make sure you're in degree mode, and we'll round to the nearest hundredth. Plugging it in, what does your calculator say? Go ahead, try it again. We're getting an error from our calculator. See, we're getting an error from our calculator because this value right here, 2 sine of 50 degrees, is larger than 1. And our first property up here said that sine of theta has to be between 0 and 1. And that's what we're taking sine inverse of, so that's why we're getting an error. Now I don't think about this property up here. I don't try to figure this out and plug that in and stuff. I just plug it in my calculator, and if it says error, then we can conclude no triangle exists. So this is the situation where side A is too short to be able to reach the third side and close up a triangle.